Hi, I'm Kevin McCabe, a Senior Application Engineer at IDS Imaging. And today, I'd like to help guide you through using our sample source code to get started with the Peak API. Now, most of the initial testing of a camera can be done through our Peak Cockpit software. And this includes things like adjusting all camera parameters, testing the performance of a target host PC for your application, and even saving images and video out for analysis later. Of course, the other half of this initial testing is with the API, which allows IDS cameras and your application to interact. To help with this, we have an ever-growing Getting Started guide in the Peak manual. These pages will help guide you through all the fundamental operations that you need to do in the API. And at the bottom of each of these pages is a continually growing source code sample for each language. Additionally, each library, the generic API, the IPL, the AFL, and the Comfort API, each have their own dedicated documentation, which you can freely reference. Of course, sometimes you want to skip all this initial work, and the API has that option for you as well through the example source code. You'll find code samples within the install directory that address general operation of the camera as well as demo specific functionality. And a description of each is found in the code samples page of the manual. We'll set up tools for each supported language of the API, and I'll guide you through the installation of each of those tools. Since we're covering multiple programming languages, here are the links to where each language discussion starts. As we get started, I do have a recommendation for a smooth path forward. Copy the folders that contain the library and the sample source code into a directory that your user has full permissions. This will alleviate any permissions-based issues in the future and allow you to run your development environment of choice as a non-elevated user. Now, let's get to it. Before we begin, there is an alternative method for using Python that we won't be touching it on, and that's using a web application called Jupyter Notebook. You can take a look at this application note if you're interested. Now, on to using PyCharm. We'll begin by installing the Community Edition of PyCharm, but please choose the version that's most applicable to you. Now let's start the installer, and I'll choose two options here. I'll associate Python files, and then I'll add an open folder as project to the right-click menu. Now let's run PyCharm. And we can have PyCharm help us set up Python as well. So we'll create a new project. Here, new project, and we'll keep everything as default. But here, we will choose the latest version of Python, 3.12.3. And you'll even say here that it says download and install. So this should set everything up for us. Now we can close out this project. So now that we're all installed and configured, let's open up a sample. We'll navigate to our source folder and we'll choose Simple Live Qt Widgets. And we'll use that right-click context menu option that we installed previously. PyCharm will do some initial installation and configuration. So while it's doing that, let's open up all our script files. And you can see already we have an issue that you might run into as well. An invalid Python interpreter was selected. Now, thankfully, since we started that dummy project and saved it, we have an interpreter already set up for Python 3.12. So let's use that one. Simply selecting that should have that error go away. And now let's look at our dependencies and install some packages. If we start with this simple live Qt widgets script, we'll see we need PySide 6. Sys is already something that's included. We could install PySide 2, but let's go with the latest PySide 6. On some installations, you'll find that PySide 6 could be included already, but let's install it just so we have everything. Now that's installing in the background down here. Let's keep looking for other dependencies in our other scripts. We see sys again, PySide again. Here, we have the IDS Peek library, so let's install that through PyP as well. We search IDS Peek, and we can install the latest version. And we have the IDS Peek IPL as well. So let's install that. And on our last display.py script, we only have an included package and just some PySide 6 things again. So we should be all set. Once this is installed down here and completed, let's hit play and see what happens. Now that because we don't have a main script installed, we need to make sure we're on the main script, which is this one. And here we go, a live image. For our C#.NET explanation, we'll be using Visual Studio. And C# is thankfully very straightforward to use within this environment. Our examples include .cs project files in each directory. And some examples also include a .cs project file with _framework, which uses the .NET framework instead of just plain .NET. You should consult with your software development colleagues whether you should use this version or the other. We'll move forward with .NET though. Note that all of these examples use the unsigned binaries, but if you need signed binaries, you can find them within the library folder right next to their unsigned counterparts. Let's grab Visual Studio from Microsoft's website and continue with the installation. So we'll run the Visual Studio installer, we'll hit continue here. It'll do some downloads. And now we can choose our either individual components or workloads. In this case, we will use the .NET Desktop development option here. And for C++, we'll use the desktop development with C++. Now, Visual Studio installer will do a bunch of downloading, so we'll cut here and see after the downloads. So Visual Studio is all done installing. We'll hit OK, and we'll just go ahead and launch it. We can skip the login, choose the theme, and let's open a project. Through here, we'll navigate to our source folder again, and C#. And this time, let's open up the Simple Live Windows forms. project, and we'll click the CS project file here and open it. And now that we're all opened, let's just try running right away. And we're hit with an error. So we have to install or update .NET to run this application. So we can choose either to download it here, but instead I'm going to retarget the project to .NET 8.0. So we'll say no here. To update, we'll right-click the Simple Live Windows Forms C# project and then click Properties. And after it loads, we see we can change the target framework here. And we can change it to .NET 8.0 because that's the version that is installed with our options. So let's try running it again. And just like that, we're up and running. If you do end up swapping .NET versions back and forth during this process, you may run into a framework issue like the one shown above here. This can be worked around by going into your projects folder and deleting the bin and object obj folders, closing out Visual Studio and restarting. This will force the project to repopulate those folders and hopefully alleviate the issue for you. For our C and C++ examples, we opted to use CMake to ensure developers can choose their own development environment easily. Additionally, our development team focused on using a cross-platform framework called Qt, so that the majority of our examples would also be useful for users in Linux. This does mean in order to run many of our examples with a graphical user interface, we will need Qt installed. Let's grab Visual Studio from Microsoft's website and continue with the installation. So we'll run the Visual Studio installer, we'll hit continue here, it'll do some downloads. And now we can choose our either individual components or workloads. In this case, we will use the .NET Desktop development option here. And for C++, we'll use the desktop development with C++. Now, Visual Studio installer will do a bunch of downloading, so we'll cut here and see after the downloads. Now that we've installed Visual Studio, let's go ahead and install Qt. The easiest path forward is to download the Qt Online installer, but that also requires you to create an account on the Qt website. Once you've done that, you can click this Getting Started link under the Looking for Qt Binaries section. We'll choose Windows. And for this demonstration, we are going to be using the open source version, but you should discuss internally whether it makes sense for your company to use this version. Let's run the installer we just downloaded and log in. Make sure you've verified your account here or you'll get an error. Now again, make sure open source is right for you, and then we'll continue. Here we'll choose custom installation, and let's expand Qt here. The version we're looking for isn't here. So in order to see version 5.15.2, we need to click Archive here and Filter. And now we scroll down. Here it is, 5.15.2. And as for the developer and designer tools, you don't technically need any of these, but I've opted to keep both of these tools, but we will install CMake on its own as well. This will take a long time. We should cut here. Next, we'll install CMake, a powerful cross-platform build environment. We'll click the downloads here, and for us, we'll install the Windows 64-bit installer from the binary distributions. Installing CMake is somewhat unremarkable, so we won't spend time here. Just ensure you use all of the default installation options. For our example, we'll choose source code that uses the Comfort C library. Comfort C was designed with convenience in mind. It provides a simple approach to camera control with easy-to-use functions for all essential camera operations. As an example, in Comfort C, the buffer allocation is built right into the peak acquisition start function call here. Now, generic C++ also has an automatic image buffer allocation, but it requires about 10 lines of code instead of this just one here. Conveniently, Visual Studio has the option to open a folder with source files contained in it, and if it has a CMake lists text file, it will automatically try and create a project from it. So let's open our Simple Live Qt widgets sample. Right away, Visual Studio will get to work trying to create a project. And unfortunately, we're met with an error here. This error is essentially telling us that CMake doesn't know where to look for the Qt5 components. So we need to give it a better clue as to where they are. We can double click here and we'll open the CMake lists text file and edit it directly. If we scroll up here, I've had success adding it just near the top, and we'll set a CMake prefix path. And this will give a clue where CMake should look for the Qt5 libraries. In our case, C Qt 5.15.2, and under our generator here. Now we'll save this, and we should re-trigger an attempt to create a solution. And let's try this out. Just like that, we've got a running project. As an alternative method, we can use the CMake GUI to create a project instead. So I've already browsed to the source here, and we'll also need a build folder. Let's create it here and select folder. Now we configure. We'll specify our generator here, the latest version of Visual Studio that we have available, and we'll use the default native compilers. CMake will do some work here. And we have a bunch of names in red here, but everything seems to be in order here. For you, you may need to point CMake to the correct Qt5 directory. So make sure that you navigate to the Qt directory 5.15.2 underneath your generator, or the closest one possible, and under library CMake Qt5. Once this is set, you should not have any more issues. And now let's click generate. And now we have our project. Pretty easy. Let's open the project. Now what we need to do here is we need to adjust the startup project to the correctly named project and start debugging. So we'll right-click Simple Live Qt Widgets C here, and click Set as Startup Project. And then let's run it. And we're up and running again. There we go. For guidance on your next steps, I'd recommend watching the How to Use IDS Peak Machine Vision SDK video. And as always, you can reach out to our machine vision consulting team for help at any time. Thanks for watching, and see you next time on the IDS Vision channel.